Right, so we need to find the general solution to the trigonometric equation below. And to do this, we start as follows. So we say the sine of 1/2 x plus 15 degrees is actually equal to the cosine of twice x minus 15 degrees. Right, and we analyze this and we realize that these are co-functions of each other because the co-function of the sine is the cosine and vice versa, the co-function of the cosine is the sine. And so we proceed as follows. So the sine of 1/2 x plus 15 degrees is actually equal to the cosine of twice x minus 15 degrees, like so. And this is the trigonometric sine of 1/2 x plus 15 degrees is the sine of 90 degrees minus twice x minus 15 degrees. The sine of 1/2 x plus 15 degrees. Right, so we have 90 plus 15, which is exactly the sine of 105 degrees minus twice x. And what is this? So this is exactly 1/2 x plus 15 degrees is actually equal to 105 degrees minus twice x plus 360 degrees times k, where k is an element of the set of integers. Right, k is an element of z, like so. And what then do we get out of this? So what we get out of this is the fact that 2x transpose will give us 5x out of 2. And this is equal to 105 minus 15, which is 90 degrees plus 360 degrees times k, where k is an element of z, like so. Right, so we examine these carefully and we're able to see that 5x out of 2 is 90 degrees plus 360 degrees times k, k is in z, which means we have the following. X equals, so we can multiply here 90 degrees by 2, divide by 5, plus we cross multiply, so we multiply 360 degrees as well by 2, we divide by 5, we agree together that k is an element of the set of integers, and that gives us exactly 36 degrees plus 144 degrees by k, where k is an element of the set of integers, like so. Right, and we look at this carefully and we analyze that. Right, this is not the only solution to the problem, because there is alternatively, we have the sine of 1/2 x plus 15 is the same as the cosine of twice x minus 15. And this is the sine of 1/2 x plus 15. And this is the same as the sine of 90 degrees minus 5x minus 15 degrees. This can be seen as the sine of 1/2 x plus 15 degrees. It's exactly the same as the trigonometric sine of 105 degrees minus twice x. Right, so we agree that 90 minus this angle here is in the first quadrant. And therefore, this angle itself is positive, but in view of the cast rule, the sign is positive in two quadrants. It's positive in the first and the second, meaning we can also write this as 1/2 x plus 15 degrees. Is the sine of 180 degrees minus this angle here, 105 minus twice x, like so. Meaning we have the sine of 1/2 x plus 15 degrees. It's exactly the same as 180 minus 105 is actually the same as 75 degrees. Okay, it's exactly the same as 75 degrees. So now we proceed as follows. So this becomes 75 degrees plus twice x, like so. Which means if we have the sine of 1/2 x plus 15 degrees being equal to the sine of 75 plus 2x, 75 degrees plus 2x. Right, obviously what this gives us is that 1/2 x plus 15 degrees is the same as 75 degrees plus twice x plus 360 degrees by k in the integers, like so. Upon further examination, we're able to see a couple of things. But what can we say here? Right. So we have that now the 1/2 x minus 2x becomes the same as minus 3x out of 2 is equal to the 75 minus 15 is the same as 60 degrees plus 360 degrees times k in the integers. Right, so we continue and we say x is the same as 2 times 60 divided by 3 plus 2 times 360 divided by 3. Okay, negative by k in the integers. And so this is exactly the same as what? It's exactly the same as 120 or minus 120 divided by 3. So this is the same as minus 40 degrees. And here, this one is 2 times 360 divided by 3, which is exactly minus 240, like so. By k, where k is an element of the set of integers. Okay, so we get this result here. And we observe this result very, very carefully and analyze it. Right. For example, if you substitute into the equation above, what do you get? We get minus 40 plugged in there. It gives us minus 20 degrees plus 15, which is exactly 5 degrees. Right, if you put it across here, what you get? 2 times minus 40 is actually minus 80. Right. And so minus 80 plus 75 is the same as minus 5 degrees. You can see you're getting minus 5 degrees here, and you're getting minus 5 degrees there. Okay, so this is as well a true solution if k is 0. Right, alternatively, what we have as well is that if you have the sine of 1/2 x plus 15 degrees, is exactly the same as if it happens that this is 2x minus 15 degrees. So this is the same as the cosine of twice x minus 15 degrees is the same as the following. Right. Is the same as. Okay, so you can start by writing the cosine and then writing the sine, like so. So this becomes the cosine of twice x minus 15 degrees. The cosine of 90 degrees minus 1/2 x plus 15 degrees. Like so. So what is this? This is the same as the cosine of twice x minus 15 degrees. Is exactly the same as what? Right, this is exactly the same as the cosine of 90 degrees minus 15. So if you say 90 minus 15, you're getting 75. So that's 75 degrees minus 1/2 x, like so. Right, and we look at these and we try to examine these, and what this gives us is a very good result. What result are we able to get at this point here? We're able to get two results. 2x minus 15 degrees is plus or minus 75 degrees minus 1/2 x, like so. And obviously, because we have this result here and we're interested in finding the general solution, so we add 360 degrees by k, where k is an element of the set of integers. And this is what we are able to achieve here, and you take note of that. Twice x minus 15 is plus or minus 75 degrees minus 1/2 x plus 360 times k, where k is an element of the integers, which means we have twice x minus 15 degrees equals 75 degrees minus 1/2 x plus 360 degrees times k. Or we have twice x minus 15 degrees is equal to, now you take the negative, 75 degrees minus 1/2 x plus 360 degrees times k. K is in the integers, which means you have 5x out of 2, which is 90 degrees plus 360 degrees by k, k in the integers. Or what do we have this side here? Right, what do we have this side here? Right, so we have 2x here, and then this is going to be 1/2. If you bring it up, it's going to be just 1/2, but if you bring it across, it's going to be 3 over 2x, like 1.5. Minus 75 plus 15 is minus 60. Okay, and then you have plus 360 by k in the integers, like so. Right, if you solve here, we get 36 degrees plus 144 times k, where k is in the integers. Or this is exactly minus 40 degrees plus 240 times k, where k is in the integers. And this gives us some solutions as well to the problem. Right now, the 36 degrees was obtained in the beginning. We got the 36 degrees plus 144 degrees by k. But in the second part, we got this, and we're able to achieve the minus 40. Now, this minus 40, we can see that minus 40 minus 240 by k obviously features in a wide range of places, because it was obtained after we realized that obviously the 90 minus is actually an angle acute, and meaning therefore that the sign is positive. And obviously we can say 180 minus this angle, and we'll get an angle in the second quadrant, like we can see exactly here. Right, and after having seen all that here, what then does this bring to us? What does this bring to us? Right, so it brings the 75 plus 2x. And we're able to see that the 75 degrees plus 2x is the result. And we can see that we get this here. And we get the 360 as well. And then this we get exactly like so. And this becomes the answer. Okay, right. So we have the minus 40 degrees. That's the point I'm raising. And now we have an alternative solution to this. Right, so the alternative solution is going to be the 360 plus 144. Obviously, this is 144 degrees. This one here, 144 degrees. And then we have the minus 40 degrees plus 240, which we saw before. All right, and this is actually the solution to the problem. And we're done solving this problem. Thanks everybody for your time, and goodbye to you.